Buckle up, because today we're diving into player controllers in Unreal Engine 5.5. Now, you could try to control the character with sheer willpower. Just stare intensely at the screen and wish them to move. But spoiler alert, it doesn't work. I've tried. Instead, we use the player controller. Here's the deal. Pawns are replaceable, like those cheap gas station sunglasses you wouldn't be heartbroken over if you lost. The player controller, though, that sticks around. It keeps things running between character swaps and respawns. You could stuff everything into the pawn, but that's a rookie move. Pawns are temporary, like your character's attention span. You'll lose data, break things, and generally make a mess for your future self to clean up. Don't be that person. Nobody likes untangling a digital spaghetti mess. Think of the player controller as the parent at a toddler's birthday party. Pawn, go forward, punch, jump, punch. Seriously, stop eating the crayons. We've been over this. And that's why you put the important stuff, input mappings, score, things you don't want disappearing every time your character decides to take a dirt nap, into the player controller. Why should we use a player controller? Well, it's good housekeeping, clean, consistent, ready for your game to inevitably evolve into something more complex. Character swapping, multiplayer, you know, the usual scope creep. Even for simple projects, treat the player controller like the designated driver, with the car keys and everyone's bail money. You know where to go when something breaks. Today we're building a third-person character controller. I'm going for a World of Warcraft-style setup. Holding the left mouse button lets you rotate the camera, and holding the right mouse button turns your character in that direction. It's classic for a reason. WoW, Final Fantasy XIV, Elder Scrolls Online, they use it because it works. It gives the player full control over both movement and camera, making it great for exploration and combat. Let's dive in and set it up step by step. Let's open Unreal Engine 5.5 and start a new project. I'm going to adjust the layout so everything fits nicely on one screen and you'll be able to follow along clearly. First, let's save the default map and set it as the startup map in the project settings. While this page is open, let me explain why I'm making this video. Not long ago, Unreal Engine moved away from the old axis and action mapping systems. A lot of tutorials and documentation still rely on this outdated method. In this video, we'll be using the new enhanced input system. I'll cover that in more detail a bit later. I'm going to set up my folder structure to keep things neat and start everything off by creating my character. Let's start by creating a new blueprint based on the character parent class. I'm naming mine BP Score Player. Creative, I know. To actually see our player, I'm going to drop in a static mesh. Just a simple cube for now. You can absolutely use a mannequin or any other skeletal mesh, but for this example, I'm focusing purely on movement, not animation. The mesh looks tiny, so I'm scaling it up to 3x. That feels right. I'll also adjust the capsule collider to match. After a bit of fiddling, it looks close enough. Good enough for prototyping anyway. Next, I'm adding an arrow component so I can tell which way is forward, because nothing's worse than moving backward while thinking you're charging into battle. Now, we need to actually use this player when the game starts. Rather than modifying the default game mode, I'll create a custom game mode blueprint and set the default pawn class to our new BP player. Quick test, and nothing happens. Classic. That's because the level isn't using our custom game mode yet. Once I set the level to use it, the player spawns, but the camera isn't right. We need to fix that. To do this properly, I'll add a spring arm to the player and attach a camera to the end of it. Spring arms are great. They make camera movement smooth and easy to control. Think of them as selfie sticks for serious developers. A few tweaks to the rotation and boom, player camera locked in. Now, out of old habit, I usually wrap my camera in a post-process volume. Is that necessary? No. The camera has its own built-in post-processing now. But hey, old habits die hard. I just really hate motion blur. That wraps up the player setup, at least for now. We've got our puppet built. Time to start adding the strings. Now it's time for the main event, the player controller. This is the set of strings that brings our puppet to life. First, create a new player controller blueprint. I've named mine PC-TTS player controller. I'm a fan of consistent naming. BP for blueprints, PC for player controllers, map for levels, GM for game modes, and GI for game instances. Anyway, tangent over. Once that's created, make sure to update your game mode to use this new player controller. If you forget this step, Unreal will happily ignore your controller and leave you wondering why nothing's working. Let's verify it's running properly. In the player controller's begin play, add a simple print string node. Something like player controller active should do the trick. Now, the style of controller I'm building is UI friendly, cursor visible when navigating menus, but hidden while controlling the camera. It's the best of both worlds. Click things when you need to, steer when you don't. Start by setting the cursor to show mouse cursor equals true, and use set input mode to game and UI. This lets the player interact with UI elements while keeping the input locked to the screen or window. Next, we'll need a reference to the player. Use getControlled cast it to BP player and store the result. That'll give us access to everything we need on the pawn side. Movement, input logic, camera, you name it. Once that's done, clean up your graph. Keep it tidy. Future you will thank you, and so will anyone else looking at your blueprints. The player controller needs to know what buttons and inputs do what in your game. In older versions of Unreal, we used the axis and action mapping system. Actions were simple binary triggers like jump or fire, either pressed or not. Axes handled continuous input like movement and looking, returning float values based on input strength or direction. It worked, but it was limited, especially when your game needed to support more than just keyboard and mouse. Now, we use the enhanced input system. This new setup is more modular and far more flexible. It splits input into two parts, the actions and the mappings. Input actions define what can happen, like jumping, walking, turning, crouching, or pausing. Mappings define what devices or buttons trigger those actions. You're literally mapping an input to a button, stick, or axis. This makes it much easier to support multiple control schemes like gamepads, mouse and keyboard, or touch. For this example, I created a new input mapping context called IMC Default Gameplay. Inside that, I made 3 input actions, IA Look, IA LMB, and IA RMB. IA LMB is mapped to the left mouse button, IA RMB to the right, and IA Look is tied to the mouse's XY 2D axis. That lets us track cursor movement in all directions. With those set up, we need to tell the player controller to actually use this mapping context. In Begin Play, I grab the enhanced input subsystem, apply the mapping context, and make sure it's activated. Now it's time to test. I bring out the events triggered by those input actions, left click, right click, and look, and hook them up to simple print strings. That'll confirm that the inputs are correctly mapped and firing when expected. At this point, we haven't wired them into gameplay yet, just confirming the signals are coming through. Think of it like flipping light switches to make sure the bulbs are good before you start decorating the house. As you can see, the print string is firing many times per click. That's because it's connected to the triggered pin on the input action, which fires every frame as long as the input is active. For something like mouse movement, that's perfect. But for button presses, that's way too much noise. So instead, I'll connect it to the started pin. This only fires once, right when the button is first pressed. Much cleaner. I could also use the completed pin, which fires when the button is released. Actually, let's hook that up too so we can see both the press and the release. That gives us better control and better feedback. Now, since I plan to change how the mouse behaves depending on which button is held, left or right, I'll set up a couple of Boolean variables, LMB held and RM held. These will track whether each mouse button is currently down. Let's check what we're getting from IA Look. Each frame, it returns an action value, which is basically the mouse delta, how far the mouse moved since the last frame. Negative numbers mean movement to the left or down on the screen. All right, enough testing. We've got input, it's mapped, and it's behaving exactly how we want. Let's make the player move. we need to break up the look event into different behaviors depending on which mouse button is held. If the left mouse button is held, we want to move the camera. If the right mouse button is held, we want the player to turn and move in that direction. And if no buttons are held, neither the player nor the camera should move. We're just showing the cursor for UI interaction. To move the camera, we'll be adjusting the spring arm's rotation. We'll need two variables, yaw rate and pitch rate, so we have fine control over how fast the camera swings around. Here's the logic. Grab the spring arm's current relative rotation, add the mouse delta values multiplied by the movement rates, and then set that new rotation back onto the spring arm. That gives us smooth, real-time camera rotation. Now for a bit of control. I like letting the camera spin around the player freely on the yaw axis, but for pitch, it needs limits. We don't want the camera flipping upside down. So I'm clamping the pitch angle, minimum miter 50, maximum 10 feels right for now. This keeps the camera from going too high or too low. Another important touch, when the left mouse button is held, I do not want the cursor showing. And I definitely don't want users accidentally clicking a UI button while swinging the camera around. So, when LMB is pressed, I hide the cursor and switch input mode to game only. When it's released, I bring the cursor back and switch back to game and UI. I'll wrap this in a couple of clean functions so we can use them consistently wherever needed. There's one more detail that's always bugged me. When you switch to game only, the mouse gets snapped to the center of the screen. And when you switch back to game and UI, that's exactly where it reappears. It feels jarring. To fix that, I'm storing the mouse position before hiding it and then restoring it when we bring it back. I'm also setting the mouse to start in the center when the game loads. Small quality of life improvement, but it makes a big difference. One caveat, if you try to store that mouse position too soon, it doesn't always work. Unreal's still getting things ready, so I added a tiny delay to give the system time to catch up before saving the position. With a bit of cleanup, the LMB-based camera movement is ready to go. For the right mouse button, we're handling movement, specifically player rotation. Since this is a character-based controller, we can adjust the player's facing direction using Unreal's built-in control rotation. To rotate the player, I use Add Controller Yaw Input. That takes the mouse's x-axis delta, multiplies it by a custom turn rate, and applies it as yaw. Clean and simple. As for pitch, we're not using it to rotate the character in this setup, so we'll just treat the camera pitch the same way we did with the LMB controls. No need to overcomplicate it. Now that we can look around properly, it's time to move. Let's start with forward and backward movement. I created a new input action called IA Forward. By default, input actions are set to a Boolean value, great for buttons but not for directional movement. We need an axis. So I changed the value type to 1D axis and added it to the input mapping context. Now here's the trick. I mapped two buttons to this single input, W and S. W should move us forward, S should move us backward. You might think, wait, how can one input do both directions? Easy, we use scalar modifiers. W gets a +1 scalar and S gets -1. That means pressing W sends a value of +1, pressing S sends -1. I ran a quick test with print string and the values came through exactly as expected. So now when the action value is greater than 0, we're moving forward. When it's less than 0, we're moving backward. And what about 0? Well, that's theoretical. 0 would mean no key is pressed, and that won't trigger the event anyway. To actually move the character, we get the forward vector based on the player's current facing direction and plug it into Add Movement Input. That'll move the player in the right direction based on our input value. One last tweak. I want the player to move at half speed when walking backward, so I divide the input value by 2 if we're going in reverse. That makes the movement feel more grounded, like the character is being cautious or retreating. And that wraps up the forward and backward movement. It's responsive, predictable, and I'm pretty happy with it. Strafing, or walking sideways, works exactly the same way as forward and backward movement. The only difference is the direction vector. Instead of using the forward vector, we use the right vector. I created an input action named IA Strafe and mapped it to A and D. Just like before, A gets a negative scalar and D gets a positive one. That way, pressing A moves the character left and D moves them right. Since both directions should move at the same speed, I don't need to treat the values differently. Positive values move right, negative values move left. To keep the movement from feeling too slippery, I scale the input value by 0.5, cutting the strafe speed in half. The result feels much more controlled. Now, the player can walk sideways based on the direction they're facing, just like a proper MMO-style controller. Next up, I want to give the player the ability to rotate using the keyboard, similar to how the right mouse button turns the character. I created a new input action called IA Rotate and mapped it to Q and E. Same pattern, Q has a negative scalar, E has a positive one. The logic is identical to the RMB rotation. Take the action value, multiply it by a rotate rate, and pump it into add controller your input. Positive rotates the player to the right, negative to the left. At this point, I realized I had no consistent way to control the speed of all these different inputs, so I added a few variables, one for rotate rate, one for strafe rate, and one for back pedal rate. That gives me full control over how fast the player moves and turns across all input types. Finally, let's add jumping. I created an input action called IA Jump, set its value type to bool, and mapped it to the spacebar. When pressed, I call the built-in jump function on the character. When released, I call stop jumping. That's all it takes. And with that, the movement system is starting to feel complete. Forward, back, strafe, rotate and jump, all in place and working cleanly. There's a small annoyance I ran into. When I move the camera using the left mouse button and then start moving the player with the right mouse button, the character just walks off in whatever direction it's facing, completely ignoring where the camera is looking. It feels disconnected. What I really want is for the player to snap turn and face the same direction as the camera when movement begins. To fix this, I grab the yaw rotation from the spring arm and set that value to the player's rotation. That way, the player instantly aligns with the current camera angle. I wrapped this into a function and called it when the player starts moving forward. Problem solved. Now, when I package the build, I'll need a way to quit the game, especially for testing without needing to Alt-Tab and kill the process every time. So I made one more input action, IA Quit. It's mapped to the escape key and it simply calls quit game. Simple, effective, and saves time. Then, at the very last second, I decided to add a camera zoom. I created an input action called IA Camera Zoom and mapped it to the 1D axis of the mouse scroll wheel. Scrolling up gives a positive value, down gives negative. That input value gets multiplied by a zoom rate, and the result is applied to the spring arm length with clamps in place so the camera can't zoom too far in or out. That gives me dynamic camera control, and it makes exploration feel a lot more responsive. With that done, I packaged the build and tested everything. Movement, rotation, zoom, jump, quit. All clean, all responsive. The player controller is ready. And that wraps it up. We've built fully functional third-person player controller from the ground up using Unreal Engine 5, complete with camera control, directional movement, keyboard rotation, jump mechanics, and even a few quality-of-life features like camera zoom and a proper way to quit the game. Hopefully, this gave you a solid understanding of how the player controller, enhanced input, and clean blueprint design come together to create smooth, responsive character movement. If this tutorial helped you, or if you learned something useful for your own project, consider supporting the channel. So if you want more clear, no-nonsense content like this, hit like, subscribe, and turn on notifications so you don't miss the next video. Thanks for watching, and I'll see you in the next one.